Steam Turbine 505 Governor Control System Explained. Welcome to my YouTube channel. I am Engineer Umar Woodward. 505 Governor Control System. 505 Governor commands the actuator to how it controls the hydraulic system and step-by-step throttle valve operation. The 505 Governor is an advanced microprocessor-based control system developed by Woodward. It's primarily used in steam turbines to maintain and control RPM, revolutions per minute, of the turbine, manage electrical load sharing, and provide safe startup, loading, and shutdown operations. This system communicates continuously with other control systems like the DCS, turbine protection system, and the actuator hydraulic control system. Main function of the 505 Governor. The primary job of the 505 Governor is to regulate turbine speed, control the load, send command signals to the actuator for positioning the throttle valve, ensure smooth turbine acceleration and deceleration, maintain system stability during load fluctuations. Let's now dive deeper into how the Governor works with the actuator and hydraulic system to achieve all this. How the 505 Governor sends commands to the actuator, step by step. Step 1. Sensing parameters. The 505 Governor continuously receives turbine speed via magnetic pickups, steam inlet pressure, throttle valve position, load feedback from generator output. Step 2. Speed and load matching. When there's a mismatch between actual RPM and set RPM, or when the electrical load changes, the 505 Governor calculates how much the throttle valve needs to open or close. Step 3. Command generation. The Governor sends a control command, 4 to 20 mA or PWM signal, to the electro-hydraulic actuator. Step 4. Actuator movement. The actuator receives this signal and regulates the flow of high-pressure hydraulic oil to the piston. Step 5. Hydraulic pressure moves the piston. Hydraulic pressure moves the piston, which then mechanically adjusts the throttle valve. Open-door throttle valve operation, step by step. The throttle valve controls how much steam enters the turbine. Here's how it operates step by step. 1. Valve closed, startup. At turbine startup, the throttle valve is fully closed for safety. 2. Initial opening. Once the turbine reaches minimum turning speed and lube oil systems are confirmed operational, the 505 Governor sends a signal to begin slowly opening valve number 1. 3. Stepwise opening. Depending on the load and RPM requirement, valve 1 opens slightly. If more power is needed, valve 2 is then opened. Then valve 3 follows. This stepwise opening prevents sudden steam rush, avoids rotor overspeed, allows smooth synchronization with the electrical grid, maintaining turbine RPM. RPM is the most important factor in turbine operation. The 505 Governor compares actual RPM with the set point, e.g., 3000 RPM for a 50 Hz system. If RPM drops, load increases, the Governor opens throttle valves more to increase steam flow. If RPM rises, load decreases, the valves are closed slightly to reduce steam input. This regulation happens many times per second to ensure precise control. When the generator is synchronized to the grid, electrical load demand varies constantly. The 505 Governor ensures load is maintained by adjusting steam flow to match the electrical output. For example, if load increases suddenly, like more motors start running, the Governor increases steam input by opening throttle valves. If load drops, it reduces steam flow. This helps maintain frequency stability and avoid overloading. Safety features of 505 Governor. The 505 Governor is equipped with multiple safety systems. Overspeed trip protection, high exhaust temperature protection, steam pressure limiters, shutdown on oil pressure loss. It can communicate with emergency stop valves, ESV, and trip solenoids to shut down the turbine safely. Testing the Governor system. Before startup, several tests are performed. Governor response test. Check how fast the actuator responds. Valve travel test. Ensure throttle valves move across full range. Setpoint matching. Test if governor holds the set RPM, load under varying conditions. Simulated load drop test. These tests ensure the governor will perform safely and reliably during operation. Components involved in the system. Main components. 1. Governor controller, 505 panel. 2. Electro-hydraulic actuator. 3. Hydraulic oil system. 4. Throttle valves. 5. Feedback sensors. 6. Human-machine interface, HMI. 7. Communication links to DCS, PLC. These components work in coordination to ensure safe and reliable turbine control. Loop of control, closed-loop system. This is how the feedback loop works. 1. Operator sets desired load or speed.